Welcome everyone. Today I'm doing my own intro, which is not necessarily entirely planned. We just had a last minute mic switch on Malcolm Sharp's end. Today, my name is Rob Stark and I'm presenting from Fortress Interlocks. We are presenting a webinar on safe access to machinery in the wood, paper and pulp industries. Joining me is Malcolm Sharp. He's basically our marketing director, but also a safety standards guru at Fortress. I'm also joined, waiting in the wings, is Eve Edwards, who chime in a little bit later. Eve is our US specific safety standards specialist. In terms of what we'll be doing today, we'll be doing a quick touch on standards. We won't take very long. We'll try not to bore you. It'll be around 30 minutes with some time for some questions. And really, we'll be looking through typical applications, lots of pictures, bits of advice, bits of knowledge, and some things for you to take away. Probably sort of without further ado, we'll get cracking. We can see most of the people are sort of joining in and we'll go through a bit of an agenda. So like I said, around a 30-minute overview of applications for controlling access in the wood, paper and pulp industry. We'll look some stuff on the wet side of the facility. We'll look at safety standards like I mentioned. We'll then start looking around how it's possible to implement these things. We'll look at maybe some alternative processes you'll have sat alongside paper production. Then we'll get into converting, packaging, and we'll even touch on some wood processing at the end. Wood processing at the end probably tends to be a bit less interesting, but it's worthwhile having a look at maybe a different approach to technology, which may be of interest. I know most of you joining today are from the paper and the converting type backgrounds, so we'll probably get started. Fortress does a lot of business in the paper industry, and of course with our partners Powermation based in the Greater Midwest, it's sort of the home of where a lot of paper industry happens. If we have a look at through the processes, the reason that Fortress does really well or tries to do really well is that the processes tend to be a little bit on the dirtier or the messier side, which suits our value proposition. This is actually a picture I took from a facility. I took this on a site visit. It was a fairly interesting picture. There is a Fortress product in this image if you can try and find it, but this was wet side of the plant. That was manufacturing paper, and they also performed the converting at the same facility. That was just sort of in the other part of the plant. However, where we were, wash down the environment, whole body access applications, people wanted to get under the rolls through these gates. They also wanted to go in, clean the machine and similar. Lots of debris and material made it really impossible to really see inside these gates or use something like a laser scanner or a light curtain to detect people during these applications where they're accessing under the machine, and maybe they don't want the machine to run, and maybe they want to see that the person's there. There were some real low visibility dark areas as well, and overall a high amount of danger. One of the more dangerous facilities I've been to, purely because of the speed and everything that was going on. Hopefully I've filled enough time there for you to all spot where the Fortress product is located. But for those of you that haven't seen it, we will hint at it. It's a guard lock. It keeps the guard lock during the rundown time of the rollers, and it only allows the door to open when, or only allows the machine to run when the door is closed and locked. The Fortress product is then here in that nice blue circle. It's a stainless steel product to resist some of the corrosive atmosphere and also some of the environment when it comes to its IP69 rating. In terms of what it looks like as a guard lock, it looks a little bit like this. In this application, it was power to unlock with 24 volts. So the supply 24 volts unlocks it, and then inside two normally closed circuits to give a dual channel safety interlock product as well. You can also see on this slide that another question that's sort of been asked there is that, well, I hinted at the whole, you can't really use a laser scanner in that environment. You can't really use a light curtain in that environment. But there's nothing in this application that you might see at the first sort of get-go to say, well, what actually mitigates the risk of that operator being trapped behind that guard closing and the machine running? We've said the machine will only run when the guard is closed and locked, and we've got this lock on the guard to stop people going in unless the machine stops. But what stops someone being trapped on the inside? Well, it's a slightly different approach to the application than maybe we typically see, where this was actually a push gate system. In terms of how you opened it, you didn't hinge it or you didn't slide it like a traditional door. You pushed it into the area, and that gate was always in front of you while you're inside the area. There was a gate on the other side that did the same thing, coming back towards you, but overall it looks like this image on the left here is that you can see you push that gate into the area, you're always on the outside of the fencing. You can never be trapped inside. It shows there's always a few different ways to solve a problem. However, it's not necessarily the most common way we see this problem solved, and it's not necessarily what we see recommended in the standards to solve this type of problem. There is a few standards that govern safety in America from an ANSI's perspective, and then also those standards tend to be quite useful and offer some recommendations, as boring as they may be. I'm hoping Eve comes off mute at this point to then talk a little bit about what the recommendations are for accessing machines under the paper rolls, where it might be a non-observable or undetectable location.
Yeah, absolutely. I'm not sure what you're suggesting about standards being boring, but anyway, there are the B1119 standard is the one that kind of focuses on risk reduction measures and the requirements of them. And as you said, especially in these paper manufacturing areas, can be very dusty and dirty, and often, as you can see there, dark in fact. And so if you've got something where someone could be inside and they couldn't be observed by the person resetting the machine, so if maybe someone could be hidden behind something or in that dark area, then after that you can try and use presence detecting. It's often not very practical in awkward areas or in particularly dusty environments. You're not going to, your light curtain and your laser scanner probably aren't going to work that well. And then the next best thing to do is to use inhibit functions. And those are going to involve anything that will stop you from being able to be trapped inside. And so I believe what you're wanting me to talk about here is the safety keys, which are an inhibit function, a proactive inhibit function, which gives you personal control when you're going inside. While you have that safety key with you, you know that the machine can't be reset. And that's kind of as opposed to a reactive inhibit function, which would be something like an escape release. But yeah, so proactive inhibit functions are really, really good in this if you're not able to see someone when you're resetting, and it gives them that control to know that while they're inside, they're going to be safe.
And that's exactly why I love the picture on the right of this image. Not only is it a picture of a real application that captures a Fortress product quite well in focus at the front of the view, it allows you to ask a question when you look at that picture to say, if there was someone stood inside that area on the other side of the guarding, would you be able to see them when it comes to resetting that safety system? My answer to that question is no. I don't think you can reliably say that you could see someone. Therefore, you must have a piece of technology which gives that personal control to people entering inside the safeguarded space to say that the machine shouldn't be restarted while they're inside. And as you can see, ANSI, as a standards organization, pulled that out with those few bullet points on the left. In terms of what it means in terms of technology and how it works, though, we'll have a look at the next couple of slides where what we're talking about when we're providing proactive inhibit functions, we tend to talk about safety keys. Fortress has a couple of different ways of forcing the extraction of safety keys, removing really as much requirement as people to remember to do the process. In terms of how this works, this is a solenoid controlled, if we're looking at the product in the middle, solenoid control body at the bottom, that won't unlock until 24 volts is supplied. But importantly, the gate won't open until that key is also turned and removed. What forces it to be removed is that hairband shape or that cheese wedge shape over the top. And you need to remove the key, and that cheese wedge or that hairband needs to be lowered over the lock portion to confirm the key is no longer present. And then at that point, the guard can mechanically open. I did say there was a couple of ways of doing it. This is the most common application. This tends to be what we see on new installations when people are making these or designing these machines. They'll design this in as part of their safety system and put it on a specification. However, what we're seeing, especially from a customer in Europe that had a lot of machines already in their facility and were looking to retrofit this type of personal control to guarding, they asked us to develop an interlock blocking device. That's on the right of this image. So we do call it an interlock blocking device. What it is, it's a retrofittable safety key that operates exactly how I said. You can't open that door until you remove that key, put it in your pocket and keep hold of it. It might not make a lot of sense of how this operates. We'll talk a little bit about it at the end, and then we'll also direct you to, there is a video on the Fortress Interlocks LinkedIn page which shows exactly how this works for you to go and have a look at after. Hopefully that makes a little bit of sense on safety keys, starts to introduce the fact if you can remove these keys, keep them in your pocket, it blocks the guard from being closed. In terms of what it looks like in those applications, we hinted at a little bit at the picture, and you can have a interlock assembly which incorporates this whole thing together. So in the picture on the right, you can see it installed. In the picture on the left, you can see what it looks like as an image render. Solenoid lock at the bottom, safety key adapters. Importantly here, 2 keys are included. So up to 2 operators can keep one on both on their persons. So it's not just the first person, it's also the first and the second person. And you can also see here is not only have they gone for that proactive inhibit function of a safety key, they've gone for that reactive inhibit function of also included an escape release adapter. So if anyone ever was locked inside of a guard or couldn't maybe get out of the door that they came in from, they would be able to hit that escape release and escape out. And then alongside the unit, some IP69 push buttons as well to give you a request to enter and a reset, or a request to enter and an indicator light to say, okay to go. All partnered up with receptacles, and then it looks like that might be Turk cabling on the bottom. Hopefully that's covered a little bit on the wet side of the plant. We're now going to do a bit of a veer off to maybe something that you'll also have at your facility, which is worthwhile considering as well, and also allow Eve to jump back in to talk a little bit about recycling that waste material generated alongside the process.
Yeah, so this is, if you don't recognise it, a picture of a recycling baler, and you can see that there's kind of a conveyor that goes up on that angle, and then everything drops in, and there's a massive kind of hydraulic ram which smashes everything together at really quite a lot of pressure, and can be pretty dangerous, and so it's really important to interlock it. The European standards actually specify kind of exactly how you should interlock the balers, recycling balers in this situation. You've got EN standards there for horizontal and vertical. There's no specific American standard on it, but it's always good taking best practice from other places as well. And what that specifies is a trapped key system that you can see here. So you'd isolate the power on the blue unit. When that's off, you can release that key. That one key goes into the bank of 8 or 9 keys there, which only when that's in there and trapped, you can then release any number of the keys which go to different doors. The specific thing you have to have is a separate key for every different access point there. So this is a really classic trapped key system. You've got one key controlling the power, and then that goes into an exchange box, which can release however many keys you require. And you can't get that key back out. You can't turn the power back on until all of those keys are back and you know that all of those doors are shut. And you can see there on the kind of blown up one on the door, it's probably a bit tricky, but on the blown up one, you can see there's also a safety key there in the way that Rob was describing safety keys working. So if anyone's got one of those safety keys, they know that you can't put it, you won't be able to release the key back to the exchange box, which means you can't release the key back to the power. So if you're holding that safety key, the machine cannot be turned on while you're in there.
Perfect, thanks Steve. Biggest thing for me there, the number of access points and the amount of wiring need to go to every single access point there. Using keys to transfer that process allows you to meet safety, a high safety integrity level or performance level, as it'll be called, but do it all through mechanical objects and reduce all that wiring around a Baler process. Something that is available and something that we'll include in the post-webinar follow-up email is a couple of standards guidances on those. They are EN standards, so we do apologise there, but they do offer some useful guidance notes on what those standards offer, and then also how they can be applied to processes, as we know that balers tend to sit alongside these processes and are often forgotten. Now that we've done that brief little interlude across, we'll get back to a little bit more on paper. So we'll start looking at paper converting processes now. So we're less focused on the wet side now. We can go back to maybe some normal material products and maybe some nicer environments, but still we'll be looking at applying the same processes. What we're looking at here is actually a few images taken from a video from a paper facility. Starting off here, they're unloading the roll at the end. I believe this operator is just about to go in because he's just unlocked the guard. He's hit a request to enter. He's going to unlock the guard. But importantly, what you'll see here is that this door has just started to open and his hand is in his pocket. What you'll see if you ever go and find this video is that he has had to remove that key from the interlock guard, put it in his pocket, and then open the guard with the handle before doing so. In terms of after he's finished taping it up or gluing the end of the finish roll and releasing it from the winder, he'll come back out, and then in order for him to close the guard again, he's reinserted the handle back into the interlock device, and then you can see he's reaching back into his pocket to pull out that key that he kept on him while inside the safeguard space. You see the red lights on in that device. The red light would indicate that the key is out, and what we'll notice is that as soon as he reinserts that key, that red light goes off, and then in their control system, you'll see that blue light comes back on. Then they'll be able to press that blue light or blue push button, blue illuminating push button, and restart the process. Seems quite simple. Seems like we're hammering home the same point. The reason that we're sort of repeating it multiple times is that it really is easy to apply everywhere. And it really is something easy for operators to interact with, and often a lot better for a complicated safeguarded space than any other technology. One thing that did appear in those images, and something that will again go on a bit of a sort of sidetrack down, is talking about, well, what's so interesting about a handle for an interlock device? For most people, they wouldn't necessarily be very interested in it, but we do have a story to tell on this one. In terms of what handles are, we have these handles in these black bodies, and they're available with our interlock devices. Fortress prides itself on making a robust product. These have a stainless steel tongue actuator, stainless steel handles, and then aluminium alloy or a zinc alloy body. They have high misalignment, so they can account for guard drop over time, or maybe just when guards are installed, they never quite align correctly. But the most important thing to start thinking about is that these are actually strong enough to resist 10,000 newtons of retention force. And to a lot of people, that doesn't mean very much, but what it means is that really a ton weight can go and crash into a guard and the interlock is not going to break. And you might think, well, a ton weight never really crashes into a guard. Why would I be interested? Well, you might find this is a little bit more interesting. It was a bit of an interesting email to receive, a bit of an odd email to receive, not necessarily something we receive every day, but it's from a paper converting company. And they started off the email with, so on a good note, we were impressed this lock did not open, release, or break apart. But they then started to go on to say, don't worry, not just the locks took a beating, our gates are twisted and almost ripped out the floor as a roll of paper got ripped up from the conveyor and forced into the guard at the end of the process. You can read through a little bit more information there, but basically they had 1,460 pound rolls smash into the lock guard, and they ended up phoning us up, asking for a few replacement pieces just to get them back to production. The impressive thing about it is that it was still in operation, it was still working. It was just a little bit bent and causing them a problem to actually reinsert it back into the head. You can see that the only bit of damage really suffered by that roll crashing into the guard to the handle and the interlock device was the bend in the tongue. Everything else carried on operating. That machine stayed safe, and importantly, it was safe to operate again after being repaired. So from our side, nice little positive story there in the industry, and sort of demonstrating to us why we put the effort into making a heavy duty, robust product. Hopefully that makes sense, and hopefully that's obviously not an occurrence that happens regularly with you, but it may happen occasionally. We're now sort of moving on, end of the process, start talking about packaging, because one of the big things that we do when we work with end users in this industry is establish a standard that can be used across all of their processes. And importantly, you can see here the red and black Fortress devices are also used at the palletizing end of the process or the packaging end of the process. This is actually a really interesting video as well, made by a company specializing in this automation development. They're integrating ABB robots for packaging, and the main thing they're offering here is a really flexible case packaging system. Is the product can change between different production runs, and it can be really flexible to which run rate and how many boxes they go in, maybe size of boxes. They're really focused on the flexibility of the process. But what that intrinsically meant is that there's often a little bit of setup to do, either changing grippers or going in and trying to do some processes. So a big part of this system was also looking at safeguarding people as they enter into the space. In terms of what that process looked like a request to enter, and then a lamp that comes on to say, yes, this guard is unlocked and it's safe for you to enter. After, of course, the interlock unit is unlocked, they had 2 safety keys, just like the previous process that we saw, where up to 2 operators could go in, each one taking a safety key with them to prevent the machine restarting. You can also see here as well, they went for that escape release adapter. So if anyone ever was behind a lock guard or maybe was trying to get out the other side of the machine, they would be able to hit that red button and escape out. So in the video, you can see once that key's removed, they're able to pull that tongue back out of the head by using that sliding mechanism to slide it across. You can see there the red lights come on to say the key's out and the unit's unlocked. The green light's still on to say it's safe for them to enter. They do the process, whether that's making a small bit of maintenance, picking an object off the floor, or doing a major change. They complete that, and then process reverses. They leave back out, take the key back out of their pocket, reinsert it into the guard, close the guard, restart the process, and confirm basically it's safe to do so. That's probably the last time we're going to be banging on about safety keys, so don't worry about it. We'll move towards the end of the presentation. We promise not to keep you very long. The thing that we'll talk at the end is now a bit of an alternative situation of looking all the way back to the start of the process to look at wood processing. Wood processing is another big industry for us because some inherent dangers are involved, and also the size and scale of these operations. What we tend to see is that quite often there's hazards, whether they've got bandsaw blades and they need to go in and clean pulleys on the bandsaw blades, or whether they've got power operated crosscut saws and they need to go in and change a blade and they need to make sure the power is isolated while they change a blade. Or we might see stuff like timber stacking or debarking, or even wood chippers, where there might be a process just like the balers Eve was talking about earlier, where you're compacting material or you're chipping material and you might have a blockage or you might need to go in and perform something. You want to confirm it's safe to do so, but also the machine might be quite large. It might be a big hassle to do wiring to all of these access points. So you can then start looking at a few different solutions using mechanical interlocking. In terms of what this looks like, this can actually be used on some really interesting applications. This is a generic application from a wood processing facility where they'll have different zones, and basically they want to have different modes available when they have different levels of access, or the machine to run at different speeds when they have different levels of access. This is an application with 3 levels. It can be sort of scaled up and scaled down, but they have 3 levels here. Level 1 being inspection of the process, where it's all partial body access. That guard isn't big enough for you to walk in through. You're only going to be able to be viewing or reaching. And really what they wanted there was a key switch to signal to the control system that that guard was going to be open and someone's going to be doing inspection. But they didn't want to do anything massively big relating to changing the way the process is operating. They wanted to keep it running. However, mode 2, or sort of situation 2, was for pulley cleaning, where they didn't want the process to run at full speed, but they still needed the process to run in order to clean both sides of the pulley. So what they actually needed there was a key switch that turned the machine into a slow machine mode and then allowed them to open up a different guard along the process. You can see the guards are color coded. You've got a blue one and a yellow one. At this point, when you turn off the yellow switch, you can only go to the yellow guard with that coded key, open it up, clean the pulleys, and then once you're done, close the guard, return the key back to the key switch, which turns the machine speed back up to full speed again. Last sort of access level or access mode was whole body access and maybe a full more maintenance mode. And then at that point, they wanted to shut down the whole machine, confirm that the power is isolated by locking the disconnect box in a fixed position. But maybe there was a rundown time and they wanted to make sure that process had stopped. They wanted to make sure the blade had stopped spinning. So they incorporated a time delay device. That time delay device operates in that you take the red key, you insert the red key. Once you insert the red key, you start a timer. That timer can be 30 seconds, it can be 5 minutes, it can be sort of programmable on site because it uses a Pulp programmable safety timer inside. Once that safety time has elapsed, you can then remove the orange key from the top, take the orange key to the door, unlock the door, and then the safety key is making another return there. You release the other key, keep it in your pocket, walk inside, perform the maintenance activity, confirming that the guard can't close behind you, the machine can't restart without you coming back out. Hopefully that makes sense. It also is something else that's defined in standards for a couple of different applications. Eve, I don't know whether you want to jump in and talk about a little bit about lockout tagout, define it, and then also talk about how this can be an alternative means as well.
Yeah, so you're probably familiar with lockout tagout. It's a big part of some of the OSHA machinery safety standards things. There's also the Z244.1 standard, which has both lockout tagout and some alternative methods. And actually, if you do require full lockout, it's worth noting, especially if there's rundown times and things, that it's not necessarily keeping you safe straight away. So you can lock out your power, but there may still be a rundown time. And with saws, that's fairly common. And also the other thing about lockout tagout is it's not actually forcing that process. And so a thing that we'll recommend if you do require kind of full lockout is to join it together with a trapped key system. And that's what we've shown here. So this is on the left there, there's an isolator, and that can be locked out kind of in the normal manner, or also it can be locked out through the padlockable dust cover on a bolt module there. So that bolt module, you can only release the key from it when the power's isolated, because you can see it goes into the cam. And so in order to get that key, you have to have isolated the power. You can then lock that off as required as per your process. But once you've got that key, you can then, as Rob said in the previous thing, you can start a time delay unit, for example, or in other applications, you could take it straight to a door module, depending on what you want to do. And that just incorporates the kind of requirement of the lockout tagout and the actual forcing of the process and the safety element of the trapped key without adding too much extra kind of process for people to do. And it just makes it that the process has to be done in order. And it's a great way, if there's multiple power sources as well, of ensuring that every power source is correctly isolated before you go in.
Perfect, thanks Eve. After that gives a bit of an explanation to say that lockout tagout can be used alongside trap key, and if anything, trap key enhances it by forcing the process. Doesn't necessarily replace it entirely, but it adds that alternative means alongside. Now, we're running up, sort of getting close to that 30-minute mark we promised. We've got a few more things to talk about left, but we want to do a quick overview of what we've talked about and sort of what we've gone through. We've talked about a quick overview of applications. First application we looked at was how safeguarded space in paper processing can be one of the toughest places to provide access controls to, based on the environment. Environment tends to be fairly wet, fairly harsh. Other thing that we talked about, hopefully through a few different applications, is that safety personnel keys provide a simple but effective risk reduction measure during whole body access. We've got one more slide on this, so please do pay attention to that. And then also the thing at the end that we talked about when we looked at some of those other applications was that simple mechanical key systems can be used to control levels of access. Doesn't always have to be complex. If you're running tight on time frame to do a project, and maybe you want to get it installed or you want to be able to retrofit it, often trap key is the way to do it. We don't want to rely too much on traditional technology though, because we do have Ethernet IP and with SIP safety and Profinet, ProfiSafe devices as well, for those maybe making those new installs and looking to make some of the cabling savings or the functionality benefits there. Hopefully that provides a bit of a summary. As I discussed, there's a couple more slides to look at. One of the things that we'll look at is the interlock blocking device from Fortress. We looked at this picture on the right previously, but we'll really do a bit of an intro of how it works and a bit of better explanation of how it works here. It's all about providing that retrofittable extractor key, and then we'll look at these pictures to show you how it works. First step of the process is that you open the guard, you pull the guard towards that interlock holder, you pull it towards that blocking plate on the device. At that point, the interlock at the top, whether that's a non-contact, a tongue switch, or a solenoid lock, the safety contact will have opened at that point, and will be generating a stop command. But importantly, the door won't be able to be opened fully. In terms of being able to open the door the whole way, you have to turn the key at the bottom of the device and remove the key. Turning the key drops the interlock blocking plate behind the guard, as you can see in that bottom middle image. And then removing the key allows that sprung front blocking plate to drop down out the way of the door and allow the door to open the whole way. We mentioned a little bit about padlocks and lockout tagout. In terms of this process, this wouldn't be lockout tagout in terms of it wouldn't be padlocking anything to do with the power source, but it would be providing a means for maybe multiple people to each put their own personal padlock on this device as well as they go in. This tends to be the most cost-effective way to retrofit or install safety keys. You don't need to make any wiring changes. You don't need to make any control system changes. You can keep running with what you've got, but have that additional level of control to access. As I mentioned, there's a video on the Fortress Interlocks YouTube channel and also a video on the Fortress Interlocks LinkedIn page that you can take a look at, which demonstrates the processes that I've sort of shown you in these images, but shows you it in a video format. That's probably a bit easier to understand than what I've explained. At that point, just looking at 31 minutes, we promise to be about 30 minutes. We'll open up for questions. I can see we've had a few questions in. Feel free to ask us a couple more. If we don't get to them all, we will answer them over email afterwards. Putting up this slide, Eve, I don't know whether you want to jump in with a couple of the questions.
Yeah, absolutely. There's been a question, I think, referring to something at the beginning of what grade of stainless steel are the interlock devices shown on the wet side applications?
Okay, so interesting question because I didn't clarify it. I talked about them being IP69 rated. Importantly as well, they are 316 stainless steel or the casting grade that's equivalent. So they are more resistive to corrosion, so that it'll take a lot to sort of make them rust. It's not like using 304 stainless, like maybe a saucepans or something in your kitchen at home. It is 316 stainless steel. So it is suitable for those submerged or wet applications. Awesome.
Another question we've had, which probably will end up coming to me, is are safety keys considered an administrative or an engineering control?
Yeah, I think I'm going to bounce that one straight back to you, Eve.
I thought that might happen. So safety keys are technically an administrative control, as they do require kind of people to deal with them and actually take them. So they're not kind of forcing a process completely, which is what an engineering control would be. However, they are what we try and do with the extractor key and also with the interlock blocking device there is kind of force it as much as possible. So it's still an administrative control, but kind of one that's pretty much forced to happen.
Cool. And probably the last question there, Eve, I think you might be able to answer it as well, is how can people find out more about the interlock blocking device product?
Yeah, well, as you said, there's video of kind of how it works up on the LinkedIn and YouTube, and there will be a webinar, kind of a short informative webinar on that next week as well. I'm not sure we've put out the links for sign up, but we'll make sure to get in contact, and if you are interested, then please let us know in the follow-up email, and we'll make sure you are kept up to date.
Speaking about letting us know about things, in theory, a post-webinar survey link has already come up as part of this webinar. If not, when you close, that will open up, and we do appreciate the feedback at all times in terms of it allows us to improve what we're doing here, allows us to make sure that we're giving you the right content. And go from there. So a little bit of warning to go from there. I can just see another question's coming from David. I don't know whether we want to try and pick that one up and just talk about that one as well. David's asked the question around, do the electronically linked locks have the ability to lock out and de-energize a process? I think the answer to that one broadly is yes. Be interesting to follow up with you, David, to have a look at the application there, because what we tend to find is that maybe on the tongue or on the handle or on the interlock device itself, we have the ability to apply padlocks. So you don't need necessarily always to have a safety key, but maybe when you open the door, you might want to put a padlock to lock the door in its open position, and you can do that directly to the electrical interlocking device. hopefully that's answered the question. But like I said, we'll follow up just to figure out exactly whether that answered that question there. Last thing then, Eve, I don't know whether you want to intro this, but there is a tiebreaker question. The tiebreaker question does come with a prize.
Yep, so there should be a tiebreaker question which will pop up in just a second. If you think you know the right answer, if you write it in the chat, and then kind of fastest finger first, and maybe one or two if we've got a few people answer correctly, can win a personally engraved fortress key, which have been very popular.
Perfect.
So, yeah.
So without further ado, the question is, which B11 standard gives guidance on risk reduction measures? And I can see a very, very quick one in the chat. I'm always amazed that people try and answer this question as quickly as they do. I do believe Eve sends them out to the registrants or something ahead of time, because she loves giving away these prizes.
I honestly don't. I usually have only decided on the question kind of 10 minutes before, so I'm always impressed that people have managed to kind of see it beforehand or something. So yeah, awesome. At least someone was listening.
Yes, perfect. And on that note, we'll keep it really around that sort of 35-minute mark. We thank you all for joining. In terms of, hopefully you've enjoyed this as a style of webinar. We try and do it a bit more informally. We try and do it a bit more engaging, lots of pictures, not very much text on the slide. As I said, please feel free to get that feedback form. In terms of who we are, we're Fortress. We're available, we're contactable. We're available on fortressinterlocks.com. And then also we've been doing this in partnership with Powermation today, one of our channel partners in the greater Midwest. So thank you very much for joining, and we will probably drop out now and hopefully have a great rest of the day all.